electronist here. What I did here, for those who don't know, this is here the red part. This is a driver with transistors for a stepper motor that has 4 wires. All these transistors are NPNs, and it is built. This board is already built in reality and is working fine. And here in the simulation is working fine as well. Let me actually play it a little bit. As you can see, the motor is rotating fine. And let me stop it. So this is the control part of the motor, or the driver. But this is the logic here. Probably the logic will include this decade counter as well, and all those 4 LEDs. But let's say, for the simplicity, is this left part of the circuit. This is the the logic. So what I wanted to do here was, I should put a title. Yeah, I didn't. Yeah, it's kind of a good title. Count to x and stop. This project, the intention of it was to make this stepper step to an angle, a specific angle, and it does in a sense, but not really, not completely. Meaning that I have to do some other permutations in order to actually switch to that angle. Too many permutations. So I want, as you can see here, you can see these 4 buttons here. They represent the idea of this project. When I press one button, it will turn a number of steps to a specific angle. When I press the other button, doesn't matter which one, if it's in order, doesn't matter. But if I'm pressing one button, it will turn to another angle and stay there and uncouple from become ANC or not connected. And when I'm pressing the button, it will do the logic again for that specific button. So this is what I could do alone, with the limited knowledge that I have about logic ICs. So this switching to a different angle of the motor, this project is to be made. That was the original idea, actually, to be made exclusively with logic integrated circuits ICs. So this is what you are seeing here. So this is counting to 16. This is the first button, pretty much. Times 2 is 16 times 2 is 32. 16 times 3 is 48, and 16 times 4 is 64. So all these four guys, they are the logic counters for these buttons, for these 4 buttons. I dragged another button here for testing reasons, but actually it is functioning. It is functioning. I managed to do a little bit. You could see it counted. Let me play it, and you will see this counter as well, because without it I cannot really do significant work without this counter. And as you can see, it's counting and then it's stopping for this specific logic counter here. But I have to reset it. Theoretically, when I'm pressing the button, and as you can see, the button is staying pressed, is not only a momentary switch, is a latching. I made it latch like that, and it's staying latch until the counting is finished. Because I don't know how to do it further than this stage. But what I'm presenting here, I'm presenting what I could do until this stage, this far. So if I'm pressing this red button here, this red circle here, it will latch. It will become a latched button. And if I'm actually, it will inverse it. And if I'm pressing, come on. Come on. What the fuck? Anyway, but yeah, it's basically this button, but I latch it like that. So right now, if I have the order of execution should be like this. When I'm pressing the button once, it'll be like this, guy. So when I'm pressing it, the moment I'm releasing the button, it will do a series of permutations. First of all, it will reset from whatever number is it counted last time. So it will do this switch here, and then it will start counting. And after it reaches the final stage of counting, it will become ANC or not connected. It will cut this. Let me stop the simulation. So this line and this line will be cut pretty much from the circuit, from the logic of the circuit. And why cut? Because this will interfere with the other logic of the other counters here. So that's why we need to cut this wire and attach the next. Let me actually show you. I will delete this wire. I will delete this wire, and we will make an abstraction of this side here. With the relays on the bottom there, and we will put the wire to the next guy here. So all I've showed. Let me actually show it here. I showed here a very good explanation I give. So when I'm connecting this X point to A, B, C, or D, one of them, not all of them, it will count pretty much. This is the logic. What I'm doing right now. I can actually read it for you from here or not. You can read it by yourself if you pause the movie. And also there is a little bit of text here, but doesn't matter. All right. So that's the text. So I'm connecting this output to the clock input of my desired counter, and this output of the counter will go to the reset. Pretty much this is the logic here. So this is completely manually what I'm doing here, because I don't know how to make it I don't know how to automate it further than this. but I'm showing you that it is working. So 16 times 3 is 48. This should stop at 48, and it is indeed stopping to 48, as you can see. And resetting it is resetting, all right, to 0 and starting counting again, and stopping to 48. Let's so you've seen this guy here that is counting to 32 to 48. Let's do it for 64. I will have to reset these lines, link again to this guy here. All right, not there. My mistake, sorry. To its clock actually. Come on, come on. Like that. Yes, this program is having a lot of bugs that we have to deal with. It's not smooth, but after you learn it, uh, so this should count to 64. And it is counting to 64, which is absolutely fantastic, and I love it because I reached until this stage. As you can see, these counters are hardwired, as you could already seen. But if I'm telling you, it's another thing. I will delete. I will reset all this and show you the counting to 16, which is the first counter here, and it's only one link here, and also resetting in the same time. This is a bit weird part. I had to scratch my head to to adapt this to the other counters here, and I figured out that way of doing it. So this will count to 16. The first counter will count to 17. But if I'm resetting, it will always count to 16 and stop on 16. It's the first counting. It's something with the simulator here, though. But it's not doing the same thing for the other counters, which is good. But I'm showing you that this, what I did until now, what I did so far, how I managed to make it work actually, until what level I managed to make it work, and I'm pretty confident with the logic. I kind of copied and pasted a lot of logic of the circuits, of course, but yeah, I also had a ton of errors. I tried the transistors; they don't really work here in the simulator. I'm using, instead of the transistors, I'm using, let me find it actually, this guy here, which is, what are you? A quadruple bus buffer gate with 3-state outputs. Because it's having a 3-state outputs, is very close to a real transistor in reality. But this is also, instead of these transistors, I use this buffer, and is not working either with that buffer. So I had to get step back and actually use relays and switch mechanical switches, because in this simulator, in this Proteo simulator, they are working with the best results pretty much. And I linked I made logical links. I don't know how they are called. Let me actually check. It's like this place wire label is called. So the connections are labeled to this guy, to avoid too many wirings here. And ground is to minus, to negative side. And pretty much this is it about this guy. Also, the frequency of the circuit is very important for that motor to spin. Actually, let me show you the motor, how it is performing. So this is 16, and it's stopping here. Let me stop the simulation, and you see 16. This is 16 is 1/4 of the rotation. Let's do it again. Kind of 1/4. Yeah. So no, 32. Let me wire it again for you. Sorry for the zooming out. Let me stop it. Put it like this. Putting it to this. From here to here. And I think it will work. Yeah. So this will get inverse to minus. What? I probably didn't connect something. No, I didn't connect it right. It's here and here, because they are yep, they are switching. So this will be 180 degrees, minus 180 degrees, as expected. The motor is doing the thing correctly. The same for 270 degrees for times 3, and 360 degrees for times 4. Actually, let me show you, because you should not believe my word. You should, especially for an artist. The clock, we want the clock. And this guy here. So this will be 270 degrees, and I will start it. It will start to count, and this guy will start rotating. So here it should be 207 minus 270. So it does rotating to a specific angle. And if I'm resetting, it will count from that minus 270 another. So you see, and if it's not actually resetting to 0, the motor is not resetting to 0 and starting counting again, which is a bug of this circuit. I didn't think too much of it yet. I didn't address this problem yet. It's still buggy. But I did a lot of stuff. What I wanted to tell you, this counter here, the clock, sorry. So this clock, the frequency is 10 hertz. If I'm increasing it to more than 10 hertz, it will not work. The motor, at least, the motor will not work, not spin correctly. If I'm putting it at twice of this value of 20 hertz, and starting again, you see, it's not doing, is back and forth, is doing the back and forth, which is pretty very annoying, and I don't know what is the cause. But like actually in reality, it was kind of the same thing. If I got over a certain limit, it was stopping pretty much, not working at all, or doing kind of the same thing. But here is way more sensitive here to the frequency that I'm giving it. it should spin a bit more faster than this. Probably there is something wrong with my circuit, for sure. For sure, it's something weird with my circuit. But what is important is that I find the proper permutations, if you want, and it's kind of working, which is good. Which is good. Also, the lower speed is a high torque, so that's a good thing. This motor should have 5 wires. In reality, I will make it with 5 wires. But here so this is a completely other problem here that I spent one day to resolve it and I couldn't. I couldn't find out a solution. Let me find a 5 wire motor for you. So these are the motors in the list. And this is the 4 wires motor that I used already. And this is the 5 wires. There is no 5 wires. Yeah, this kind of, I don't think it is. But this guy, and it's giving me a lot of problems. At least I've watched a lot of tutorials on internet about it. Use as a 5 wires motor in Proteus. And check this out. If I'm starting the simulation, really it's not switching there. Oh, okay, then usually it is switching. I don't know the exact. 1 second. Let me put a single pin. I believe it was working already with a single pin by itself. No, it was fluctuating those. No, then not like that. Let me do it like this. Still no. Let's connect a single pin. So it needs at least 1 ground. Come on. Yeah, let's put it there. Yeah, you see, it's starting rotating. These two parts were fluctuating a ton. Now they are not. Why? I don't know. The circuit. Let me reset it. But I had a ton of problems with it, and I really don't know what. You see, they are switching on off, and and let's see. If I'm connecting it, let's say like that, is not really doing what I. Yeah, in my it shouldn't do anything when I'm connecting these two wires. It's a special logic that this motor was not working at all, and I spent one day to figure it out, and I had a major bug with it. It was working by itself. For some reason, right now when I'm putting it again in the canvas, probably I deleted it from this list and I added it again right now. I don't know. I really don't know. But it was extremely erroneous behavior. It was having an extreme erroneous behavior, and I really don't know what or how. No, it was unbelievable, and I couldn't make it work. That guy with 6 pins or 5 wires, those common wires, those two common wires in the middle. Yeah, so I had to remain to this 4 wires motor here, and in reality I will adapt another circuit for the 5 wires. So pretty much this is it. And yeah, thank you very much. I hope you liked my progress here. I will not continue this project because it's impossible to make all these permutations here to actually switch from one button. It's too much. I believe it's super hard to do it. I was thinking that this will be easy or at least intuitive to do it and solve the problems along the way. And I did solve a lot of problems along the way until here. But here at this stage, I'm hitting a wall that is too hard to get over it. So yeah, shit. I will switch to Arduino mode, which is a bit more simple and more intuitive to work with. This logic level failed, for me at least. But if you are smarter than me, and I hope you are, if you can solve this puzzle, you can copy this circuit. You have it there in the forum link that I showed you. And yeah, pretty much. Actually, let me show you the actual name of the. Here is in all about circuits forum, hardware design, general electronics chat, stepping motor. Probably this link here will change over time, probably. But this name will remain, and if you search for it, you will find it. Right. This is it pretty much. Thank you very much. I probably forget something else more important, but I did cover a lot of stuff here, more important stuff. Thank you very, very much for watching, and see you later. And I hope you liked your favorite artist electronist circuit, logic circuit so far. Bye bye.